A street light is at the top of an 18-foot tall pole. A woman 6 feet tall walks away from the pole with a speed of 4 feet per second along a straight path. How fast is the tip of her shadow moving when she is 45 feet from the base of the pole? Let's let this be the light pole. We know it's 18 feet tall, so we know the length of this segment here. We know the woman is 6 feet tall and walking away from the pole. Let's let this be the woman here. And we know she's 6 feet tall, so we can label this segment 6 feet. Because she's walking in this direction, notice how this segment here would be the length of the shadow. Also notice we have two similar triangles. We have this large right triangle, and we have this smaller right triangle. Let's go ahead and let this entire length here be equal to y, and let's let the distance from the pole to the woman be x. Notice if we label it this way, the length of this shadow would be the longer length y minus the shorter length x, or y minus x. Now because the woman is walking at a speed of 4 feet per second, that would be how fast x is changing. Therefore we know that dx dt, the change in x with respect to t, is equal to positive 4 feet per second. X is increasing, therefore we know this is positive. We also want to determine how fast the tip of her shadow is moving when she is 45 feet from the base of the pole, which means when x equals 45, or 45 feet. To determine how fast the tip of her shadow is moving when x equals 45, we can find how fast y is changing, or dy dt. So our goal is to find dy dt. Now we need an equation relating x and y so we can then find the derivative with respect to t, and then use this information to find dy dt. And again, because we have similar triangles, we can set up a proportion, cross multiply, and solve for y. So looking at the larger right triangle and the smaller right triangle, notice this side corresponds to this side, so we can say 18 to 6 must equal, now again looking at the large right triangle, this side here, which would be y, must correspond to this shorter length here, which is y minus x. So we can say y is to y minus x. This will be our equation that relates x and y. So let's solve this equation for y. We could simplify 18 divided by 6, that would be 3. Let's go ahead and do that. We can write that as 3 over 1 equals y divided by y minus x. Now let's go ahead and cross multiply and solve for y. So 1 times y must equal 3 times the quantity y minus x. So again, we'd have 1 times y is y must equal 3 times the quantity y minus x. Let's go ahead and distribute the 3. So we have y equals 3y minus 3x. Subtract 3y on both sides, that would give us negative 2y equals negative 3x. Divide both sides by negative 2. Notice how we have the equation y equals 3 halves times x. So this is the equation that relates x and y. So now we'll find the derivative with respect to t, solve for dy dt, and then perform substitution using the given information. Let's go ahead and finish this on the next slide. Now we'll take the derivative of both sides with respect to t. We'd have the derivative of y with respect to t must equal the derivative of 3 halves x with respect to t. Because we're differentiating with respect to t, we do have to apply the chain rule on both sides. The derivative of y with respect to t would be 1 times dy dt, or just dy dt, equals the derivative of 3 halves x with respect to t would be 3 halves times dx dt. Remember, our goal here is to find dy dt, and now we can because we know dx dt. Notice how dy dt is actually going to be a constant based upon how fast the person is moving. It's not dependent on the value of x. So dy dt in this case is going to be equal to 3/2 times dx dt, which is 4 feet per second, notice here the 4 and the 2 simplify. There's 1, 2, and 2, and 2 2s and 4. So dy dt is equal to 6 feet per second, which is how fast the tip of her shadow is moving when she is 45 feet from the base of the pole, or actually from any distance from the pole, as long as she's walking in the same direction at 4 feet per second. I hope you found this helpful.